Hello everyone, welcome back to my channel. My name is Sanjeev Garg. Today we will be discussing new problem in our dynamic programming series, that is unique part 2. Unique part 2 is the follow-up question for the unique path 1. In the unique path 1, there is some modification that is done in this unique part 2 question. So before I start, I highly recommend you to watch my previous videos. They will help you to make a solid foundation for you and make it easy to understand for you this question. So let's get start this question. Okay, so let's first start the unique part 2. Question read, given an enclosed M maze with obstacle, count and return the number of the unique paths to reach the right bottom cell and from the top left cell. Okay, from the top left cell we have to go to the right bottom cell. Okay, we can move either in the I plus 1. I plus 1 means we can move into the down direction, and J plus 1 mean the right direction. Okay, this is the same thing that we already did in our previous question. Okay, one thing is there that a cell is given with the measure with has a value is -1 if it is the blockage or a dead end. Okay, so basically what it trying to say, if in the cell -1 is present, means this is the blockage or the dead cell. You cannot go this dead cell. Okay, let's understand this problem. Okay, unique path 2, unique path 2. How you will solve the unique part 2? So what exactly the unique part 2 is, let's get start. Okay, so let's say we have this matrix. Let's say take a 3 cross 3 matrix only. Let's say my let's say robot is here. Okay, the same example in the previous example. Okay, and wants to reach here, and in the middle there is some obstacle here. Some obstacle means there is dead end, you cannot go at this cell. So what, how many unique paths are there from reach from the source to the destination? Let's say this is source and this is destination. So either this robot can go into the down direction, or this can go into the right direction. This is the same way when at this position, when at this dead end cell. So we have to take care that condition. Okay, how we will find that whether this is the dead cell or not? If its value is -1, then this is the dead cell. It's already given into the, it's already given. Okay, so similarly if you see in as we have already done in our previous example, so at each step, let's say if I'm trying to solve this 2 cross 2, what I'm trying to do is, okay, so when I go to the left, okay, so what f22 means, okay, let's say why I'm at this position, in this cell, I'm at this position. Okay, this cell will ask to its upper side and its left cell, a how many ways to reach at you, okay, let's say if it's left cell, there is 4 ways to reach at me, and there are 3 ways to reach at me. If its upper cell says, then how many ways to reach at the our destination? Definitely 3 plus 4 ways are there, because from the 3 I can jump to the my destination, and from I can jump to the destination. So total number of the ways are 4 plus 3, that is 7 only. Okay, in this way, if we see this f of 2 cross 2, okay, it will ask to its left side, and it will ask to its upper side. If it is asking to its left side, okay, in this if you see, if it asking to its left side, row is remaining same, but the column is decreased by 1. Row is same but column is decreased by 1, so 2 cross 1. Okay, it's asking to the its left side. Now it will ask to its left side, row is same is decreased by 1, row is same is decreased by 1, 2 minus 1. Okay, -1 means there is dead end, -1 means there is nothing, -1 at this if you see in this cell, after this cell there is nothing is there, so it will return simply 0. Okay, similarly we can go with the right direction. Okay, this is left side, that asking, and each cell will ask to the upper cell as well. Okay, it asking to the upper cell. When we are going to the up, row will decrease by 1 and its column will remain same, it will ask to its upper cell and it will ask to its left cell. Okay, it will ask to its upper cell, row will decrease by 1. This is 0, this is 2, and similarly this is left and upper cell. It will ask to -1 and it will ask to, it will remain 2. Okay, so in this way, so each node has these two ways to check whether how many ways are there to reach at u. So the same thing that we already did in previous example, there is, if there is m rows and n columns, so 2 raised to power mn is the time complexity. And if you see how much depth we are going is m plus n only, m plus n. So space complexity is order of m plus n. Space complexity is order of m plus n. How we can solve this problem? With the help of memoization. Okay, memoization. Similarly, as we did in our previous example, just one thing we have to consider here. Okay, if you see in this cell, one thing that we can see here, okay, one is, this one is our outer boundary, means we cannot go here, we cannot come here. This is our, we can come here, we cannot come here, we cannot come here. One more thing, let's say if there is -1, there is -1. If there is -1, then we also cannot come here, we cannot come here, because this is the dead cell. So when we are checking the I, when we are checking I is greater than, if I is greater than 0 and j is greater than 0, means we are at this position. Our array, our dp of array should not be, our this array is should not be, I of j should not be equal to -1, should not be equal to -1. If this is the case, then we will simply return 0, we will simply return 0. So this is the one case that extra we have to handle in this question. And all the other tabulation approach is same. Okay, all the tabulation approach is same, and after that there is a space optimization. Okay, space optimization, it's also same. Okay, so we will see this in the question when we will solve the coding. Okay, so let's try to solve this question with the same example. Just one thing that we have to consider in mind that this condition we have to add, this condition we have to add. Okay, let's start with the question. So hey, let's start with the coding. Okay, so we will do the same thing that we have already done in our previous videos. Okay, we'll make a util function. Okay, this is util, and we will return this util from our return obstacle util. Now n minus 1, m minus 1, and this one is matrix. Okay, so for the let take m here, n here, this is m and this is n. We'll take the same as we did in the previous, because there m was the rows, n was the columns. So simply base case, if okay, if we are at 0, 0 means first cell, means we are at the base cell. If m is double equal to 0 and n is double equal to 0, we are simply returning 1. Okay, otherwise what we have to do, we have to calculate up. Okay, so for the util, let's go to the up. When we are going to the up, we are decreasing the row, but column will remain same and matrix will remain same. Now for left, matrix. Okay, now at last we will return up plus left. Okay, so there is one condition: when there is no up and there is no left, then m is less than 0 or n is less than 0. We will simply return 0. One more case is there in if we have the obstacle. So if we are at the right cell means if we are at the positive cell, if m is greater than equal to 0 and n is greater than equal to 0 and our matrix dot get matrix dot get of row dot get of column is double equal to -1, we will simply return 0. Okay, let's try to run this if it works or not. Okay, so array list, okay, it's saying array list is not there. Let's import java dot utils dot star. Let's try to run this. Okay, so it's running. Let's run again. Let's try to submit this, if it is able to submit or it is giving time limit exceeded. Okay, it's giving time limit exceeded. Okay, let's, you know how to solve this problem already. So dp with the help of memoization, new int this is row and column. Now you will pass dp here. Now same int dp here. Okay, so before returning the result, need to save the dp mn. Okay, so we have, okay, if dp of m and n is not equal to -1, simply we have to return dp of mn. So we have to fill this dp with -1. So for int I equal to 0, I is, we have to fill all the rows, I plus plus arrays dot fill dp of I with -1. Okay, so dp is there. dp we have to pass here as well. dp we have to pass here as well. dp is here. Before passing we checked here. Okay, before recalculating, let's run this. Okay, it's working. Okay, for the long output it's not working. Let's see in the code. Okay, modulo 9, 10 is per 9 plus 7. So what we can do, we can take private static final int, let's say mod equal to 1 2 3 4 5 6 7 8 and 7. And before storing this value into our dp, what we will do, we will just do the mode of this. Okay, it's working fine now. Let's try to run this. Okay, so we are able to submit this. Now let's go with the tabulation. For the tabulation we don't need this. We will simply use our for loop for, okay, for int I equal to 0, I is less than our row and I plus plus. Now go with the column for int I, for int j is equal to 0, j is less than n, and j plus plus and j plus plus. Okay, so if our I is double equal to 0 and our j is double equal to 0, what we are doing, we are simply putting dp of ij is double equal to 0, nothing else, and after that you do not have to go below, just continue from the loop. Okay, another one is case, let's say if we are our matrix dot get row dot get column means j is double equal to -1, then simply dp of ij is equal to 0, and now we also not going down, continue. After that we have to calculate this one, up and down, up and left. Okay, so int up equal to 0, int left equal to 0. So if to calculate the up, okay, if you see, if we are calculating the up, we have to check for the minus for the row. If I is greater than 0, then up equal to dp of, we are going up means I minus 1, and this is j. Similarly, if j is greater than 0, we are going left. We are going left means dp of left means row will remain same and column will decrease by 1. Okay, and at last dp of ij equal to up plus left. Before storing we have to do modulo as well. Okay, and at last we have to return dp of m minus 1 and n minus 1. Let's remove all this. Let's remove this one. Okay, dp of m minus 1, n minus 1. Okay, let's run this. Okay, so if we are at cell is equal to, it will come 1. Sorry. Okay, we are able to submit this. Now this is the tabulation approach. Now we'll go with the space optimization. How we will do the space optimization? Okay, let's say we have this our previous array, okay, is equal to new int as the number of columns. Now this is a dp array, let's make it as our current array, and to calculate our first current row, current equal to new int. Okay, this is telling my current row. dp of I means current row. Okay, now dp of I minus 1 means my previous, dp of I means my current, and up down dp of I means my current. Okay, once it is calculated, my previous equal to current. Now let's return previous only. Okay, so let's run this. Let's submit this. Okay, yes, we are able to submit this. So these are the ways that we can solve this problem unique part 2, from the recursive approach to the memoization to the tabulations to the space optimization. Okay, I think you got better understanding now for this problem. So if you like my video, if you enjoy my video, I highly recommend you to please comment on the video so that I can give the answer to your question if you have any questions, and it will also will be helpful for me to keep me motivated to make another videos. Thank you. Thank you.